Bismillahirrahmanirrahim. Hello, good evening. My name is Fahmi Castellow bin Hafiz, and today I will present about CI Spray combustion engine. A few things we need to know for the injection parameters, which are injection pressure, rate shaping, orifice size, and orifice shape. Explain more about injection pressures. Injection pressures refer to the pressure at which fuel is delivered into the combustion chamber or into the intake manifold in the case of port fuel injection. In diesel engines, we focus on diesel engines. It is typically the pressure at which fuel injected directly into the combustion chamber in gasoline direct injection GDI engines. It's also the pressure at which fuel is directly injected into the combustion chamber. Here, I want to show you about what injection pressure can influence. So here we can see 75% load at 1700 RPM. You can see here there are three sets of injection, which are A and B and C. A, which is high injection pressure but in short duration. And then we can see that B is low injection pressure but short duration also. And C, we have high injection pressure and long duration. Here we can see that from the injection pressure B, which has low injection pressure but short duration, has the highest specific soot. If we can see from the graph versus time, it has higher specific soot. Meanwhile, if we can see in A has a lower specific soot but at longer time. And for the C, we have which is high injection pressure but longer duration. It has initially it has very low specific soot, but it decreased until 7 times 7. Here is another diagram for the lower and higher injection pressure. We can see that lower injection pressure, which is at 100 bar, you can see that the red indicator, which means is higher soot. We can see at time after injection at 4 milliseconds. But if we use higher pressure injection, from here we can see less red indicator. So it means that less soot we can see. So the conclusion from here is that if we have low pressure, it will create more higher soot. But if high pressure and longer duration, we can have very less soot than low injection pressure but short duration. This is because high pressure we can have better throttle response and also can combust very easily lah. And for the low pressure, lower injection pressure, the fuel is not fully combust, so it will create more soot. So rate of shaping is the context that fuel injection in internal combustion engine refer to that where the fuel injection rate varies over time. The shaping is crucial for optimizing combustion and improving efficiency and reducing emission. The rate of shaping can be influenced by various factors including injection pressure, injection timing, and the design of the fuel injection system. Here I want to show you that there are three types of shaping which can be found in diesel injectors, which are the square wave profile, the ram up and ram down profile, and the multiple injection pulse profile. So here we use the graph or rate of injection versus time after start of injection, and this is from the theory on the left and the actual on the right. And we can see it's a square shape like profile. What I can deduce from this graph, the injector rate of injection time versus time and after start of injection. Square wave profile indicate that high peak rate but have constant injection rate. This means that a large amount of fuel is produced and it can produce high power, but also it can produce high amount of soot and also high emission engine stress and low efficiency. This can be found at older and simpler engine design configuration such as Caterpillar, Cummins, or pre-common rail system. Common rail system I will explain on the later slide, because common rail system is the system that we diesel car use, the current diesel car using. Here is the pattern of ramp up and down. From here we can deduce that it has high and also low peak rate injection pressure. This can cause the engine will have better fuel control and smooth, because it has higher peak. Sometimes it will go higher peak and go down back to lower peak. So it has less soot, because it decreased the injection rate by drastically, so that the engine will run smoothly. But this is not as efficient as the multiple injection system. I will explain next later. And this ramp up and down profile you can see at all diesel engine with complex advanced injection, such as the same brand Caterpillar and Cummins, and also pre-common rail system. So this is multiple injection pulse. Multiple injection pulse is the most common we can found in diesel car engine. It's injection. Here we can deduce that several smaller injection occur in single combustion. Means that there's more than 2 injection in the port. So mostly common multiple injection pulse that have in the system, which are the pilot, main, and post injection. This because it most very efficient on fuel combustion, and also quick combustion with less soot than square wave, and also the ramp up and down. I will explain more about why it's very efficient on fuel combustion. And this multiple injection pulse is very commonly found in the common rail diesel system, and every diesel truck and car have this system. I will explain more about multiple injection pulse. So pilot is the first or smaller injector which inject small amount of fuel before main. It helps to initiate the combustion smoothly by raising the temperature, pressure, and during compression stroke. It basically acts as the starter of the injection process. So it acts as the warming up for the engine. It starts to initiate the injection rate, so that it will able to run very smoothly, and the torque also smooth. And this also can reduce combustion noise and engine stress. And also the pilot also can be named as pre-injection. The next injector is the main injector. The main injector which inject the primary amount of fuel needed for the power stroke. So it provides the main energy required to drive the piston down and act as the main power. So this main injector act as the bigger injector, the main injector. During the peak, it also reduces the temperature peak and reduce the amount of NOx, because this also a function as to limit the higher peak of injection rate lah. So it reduce the soot very drastically. Last thing is the post injection. Post injection function as they inject additional fuel after combustion. Why we need why we need post injection? Because to fully complete the combustion, because the main injector, when you start to inject, it doesn't burn completely. This also helps to complete the combustion fully, and also reduce a lot of soot formation. And it also provides oxidation of the exhaust gas to increase the efficiency of the DNO catalyst. This is the example or the commonly used the common rail system which are using multiple injection pulse system, which is Denso system with solenoid actuator. Another more information about this kind of multiple injection which are commonly used on the common rail DC system. This also the another info about the post and pre injection. So the pilot and the main are the same, but here we can see that we have pre-M with injection event reduction of initial delay, thereby reducing combustion noise. And after M, short provides oxidation the exhaust gas, as same as the post-injection function. Here is another graph which indicate where is the site of NO2 and the soot. So rate of heat release. The rate of heat release, which is RR or HR, in a diesel engine refers to the rate of which the chemical energy stored in diesel fuel is released as heat during the combustion process. Understanding the rate of heat release is crucial for optimizing engine performance, fuel efficiency, emissions, and overall combustion stability. Why this is very important to know, because we can optimize the rate of heat release to ensure that the maximum amount of fuel is converted into useful work, leading to improved engine efficiency. Another is emission control. We can control emission by the heat rate release, influence the formation and combustion of pollutants such as nitrogen oxide, NOx, and particularly matter PM. By controlling ROHR, diesel engine manufacturer can reduce the emission and comply with strictly environmental regulation. It also can know about the engine performance. The timing and magnitude of the heat release profile significantly affect engine performance parameters such as power output, torque, and combustion stability. Optimizing ROHR can enhance overall engine performance and drivability. So this is the rate of heat release graph. Rate of heat release versus crank angle degree from the typical diesel engine lah. So we can see here in the initial, we can see the start of ignition start from low, and start ignition delay period, permissive combustion phase, then naik and turun balik, and start of the main injector, mixing control combustion phase, and then the end of the combustion will decrease until zero to the lead combustion phase. So there are another factor for the combustion control for diesel injection, which are injection pressure and the rate shape, injection timing, number of diameter angle and spray holes, diesel flame development, and also the diesel flame structure. The timing injection is also crucial. It's because injection timing in diesel engine refers to the precise moment when the fuel is injected into the combustion chamber during the compression stroke. The timing of the injection significantly impact engine performance, fuel efficiency, emission, and also overall durability. You can see here from the graph, we have VDTC, TDC, and DTC below, and the y-axis is combustion chamber pressure. You can see that the typical diesel engine is the dot line, and the actual one is the real red line. So here we can see the start engine pressure and injection lag, start of combustion, and then combustion pressure, pop, and habis combustion, they will decrease, and end of ignition, and end of combustion. So the pressure, we can see the pressure up and down. Two kind of timing injection, which are advanced timing injection and retarded timing injection. Advanced timing injection is the current one, the already optimized injection, which are the early injection leads to higher peak combustion pressure, which can improve power output. But also, if we have higher peak combustion, higher peak pressure, it also may increase the mechanical stress of engine component. Higher temperature improve combustion efficiency, more completely burn and less soot. Now for the retarded timing injection. Instead of we have the advanced timing, we have particular timing of the injection. The retarded timing injection is cincai lah, cincai timing. It will have lower peak pressure, which can reduce mechanical stress and engine noise. But we have it will have cause low temperature on the injector, so it may have occur lead combustion. Even though it have low emission, but it also occur lead combustion. Lead combustion will produce a lot of soot and efficient fuel burn. It will cause also less power and less torque. I did mention about orifice shape and size, that it will influence these injectors. So the size and shape of orifice in this fuel injector significantly influence engine performance, fuel efficiency, emission, and combustion characteristic. I will explain more about it. First, I want to show you what is actually orifice. Orifice is the size of the opening for the fuel to come out in the fuel injector, but not from the nozzle, from the puff inlet to the outlet of the nozzle. There's one tube is called orifice. This orifice size will influence fuel flow rate, automation and spray pattern, combustion efficiency, and injection pressure. Let's focus on fuel flow rate. If the size of the orifice is bigger, more fuel will injected, and also will cause more power, more combustion to occur. But if the orifice is too big, it will create overflow of fuel, which can cause the fuel will burn inefficiently, or also can occur unburned fuel. For the automation and spray pattern, we can see on this slide, if the spray is very little, it will combust not efficiently. But if there has very big spray pattern, it will produce more power and more engine torque. For the combustion efficiency, there also has a sweet spot of big and small size of orifice size lah. Every type of engine or capacity has their own specific size of orifice, and also the injection pressure. Here we can see the combustion pattern, which is the ideal one, and the not ideal, the small shape of combustion pressure. The small one will not produce much power, but also can reduce the emission, but it doesn't produce much power for the vehicle lah. We can see the injection pressure and orifice diameter, and here is the equation. Actually, there's two type of injector. There are solenoid type and also the piezoelectric type. Solenoid and piezoelectric injector are two types of fuel injector are usually used in the modern diesel engine. Both play a crucial role controlling the timing and quantity of fuel injected into the combustion chamber, which directly affect engine performance, fuel efficiency, and emission. So, what is the difference with solenoid and piezoelectric? So, solenoid injector use an electronic So solenoid injector use an electronic magnetic solenoid to open and close the injector needles. When an electric current passes through the solenoid coil, it creates a magnetic field that moves the plunger and armature, lifting the needle and allowing the fuel to be injected into the combustion chamber. Meanwhile, in piezoelectric injector use a stack of piezoelectric crystals that expand or contract when an electric voltage is applied. This movement directly actuate the injector needle, allowing for extremely fast and precise control of fuel injection, which means that piezoelectric has more sensitive, more accurate and more faster than it open and close for the needle, for the orifice lah, to force the fuel come out from the injector more precisely than the solenoid. So here we can see the pros and cons of solenoid type and piezoelectric type. For the response time, for sure, and of course, piezoelectric injector, which has faster response time than solenoid, faster microseconds. The injection pressure on the piezoelectric injector is very high, which is very recommended for efficient power delivering engine lah. And the cost, solenoid is more cheaper because of the simpler mechanism it use, rather than using the piezoelectric crystal lah, because piezoelectric crystal is very costly. For durability, solenoid injectors is very robust. That's why solenoid injector are commonly used in tractors, in trucks, rather than piezoelectric injector using in like Toyota Hilux or diesel car, the common diesel car lah. But the application for the solenoid injector is older and cost sensitive engine. Meanwhile, for the piezoelectric injector is for the modern and higher performance engine, which is the more modern diesel car lah. So here is the example for the diesel injection, which are this. This is a Bosch CR injector with solenoid ejector, and this is the piezoelectric injector, and we can say that it using the crystal piezoelectric that consists of 400 thin layer or disposed in rectangular module with 7mm, 40 micrometer expansion, supply of 70 to 80 micrometer of lever. It's very small opening. We can create more precise how many fuel needed to shoot out from the ejector lah. And also it close very fast and it open very fast. We can see here from the this needle lift graph from the piezo and solenoid versus time. Piezo has very higher higher open lid, and very in short time dia buka awal lagi berbanding dengan solenoid. Solenoid buka very lambat and tutup sangat lambat berbanding dengan piezo, dia buka lebih awal and tutup lebih cepat berbanding solenoid. That's it from me, and I hope you guys understand everything about CI spray injectors on diesel engine. Thank you.